Welcome back everyone. This is part 2 of chapter 1 in Form 5. Previous video of part 1 in this chapter I've shown you on arithmetic progression. This is the part 2 for this chapter, geometric progression. In what I've shown here in the screen, in red, this is a series of number. If you were given a series of number, first of all, you need to determine whether it is an arithmetic progression, AP, or whether it is GP, geometric progression, or AP, arithmetic progression. Now, in order to determine it, what you're going to do is first, you look for the first 3 digits. This is the first term, term number 1. This is my second term, second number. This is my third term, third number. Now, based on what you can observe over here, it is that the second number is either plus 2 or times 2. Therefore, you can't determine it. So you need to examine the second and the third one. Here to here is basically is therefore times 2. Then you know that it's times 2. Now, in order to answer question in your exam, to prove that it is a geometric progression, what you need to do, the term to use or the keyword to use would be a common ratio. Common ratio, R, represents by R, is T3 over T2 should be equals to T2 over T1. This is the first thing that you need to know. I put it into a square bracket. I put it into bubble. I bubble it up. In order to determine that, T3 to T2 is equal to T2 over T1. Now, let me use the number here. R would therefore be equals to 8 by 4, which is also equals to 4 by 2, which is therefore 2, which is equal to 2. So therefore, my common ratio is 2. First term, first number is A or T1. Now, what's the general equation to represent this number in the series? Just like in arithmetic progression, there's a method. The same method is used to find the general equation. First of all, you need to list out the number. We'll do it here. So that is 2, 4, 8, 16, maybe 32. Right? So the first number, you can't do much about it. Maybe the second number is 4, which is therefore equals to 2 times 2. Whereas this one is 2 times 2 times 2. Whereas this one is 2 times 2 times 2 and times 2. So here, well, 2, 2, maybe this is, I want to say this is basically equals 2 power 1. This is 2 power 2. This is 2 power 3. No. You can't do that. Otherwise, you don't have a sequence. Let me erase this and this. Well, here 2 to 1 because this number is the previous number. I'm making use of the previous number. That's why I can't have a power number here. So I'm using the previous number. I times with 2. Here, our 2 times 1, 2. Here would be the first digit, 2 and 3. You try to link the first number with the common ratio. Now, here is 3, but oh yeah, let me add another digit here, maybe a term number. Say this is my term 1, first term. This is my T2 second term. This is my T3 third term. This is my T4 fourth term. It's always the case the digit is 1 less than the power number. So therefore, based on this observation, you may deduce an equation for the term number is therefore 2, 2, 2. This is the first term, number first term, A, times R. Now this number is 1 less, so n minus 1. Minus 1. This is the term number. In order to get the term, general equation for term, this is it. I'll let you have a few seconds, go through it. You may pause my video to have a look at it. Now, once you know how to get term, next thing you learn in geometric progression is the sum. Now I'm not going to show you how do they get the sum equation, the general equation for sum, because I'm sure you can get it from reference book or textbooks. The concept behind it. So let me dive into the general equations, right? Now, in order to get the sum, Sn sum of n term. So sum of n term will therefore be equals to A times Rn minus 1 over R minus 1. Now you might not be able to memorize this at the moment because it's so new. As time goes on, practice makes perfect. First term, Rn minus 1 over Rn. There's a proof how to get it. It is that the concept of sum for a series of number is actually the first term plus the second term. Second term is A times the common ratio plus AR2 plus dot 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 and so on until it goes n. But in order to do that, the second line equation is you times it with common ratio R and then rearrange them, subtract them, and you summarize to be, and then you get this equation. So I'm not going to show here. You doesn't need to know that in this SPM level. In higher level, perhaps you need so. Next, that would be sum of infinity. Sum of infinity. S infinity. Now to do that, it's rather simple, which is equals to A over 1 minus R. It is not that it is different, it's actually the same as above. The reason to why it is being reduced to in this simple form term is that as when your n towards infinity to a very huge number, the r to a huge number, when your r is less than 1, is a decimal place. What happens is when r approach infinity, it is basically equals to 0, approaches 0. So therefore the term inside here would become 0, it left with only A. But of course, why is it different than from here? There are another version, which is from your book. What happens, it says, when your r is more than 1, then you use this equation. As when your r is less than 1, you switch. Your Sn term would therefore be equals to A times 1 minus Rn to get a positive number over 1 minus r. This is where you get to here when it's being reduced to the sum of infinity. The same rules apply. If you want to look for a little bit trick actually, Tn, well, it's good to always know that it's equals to Sn minus Sn minus 1. Take some time to take a look at this equation. What does it mean? Think about this. N term, you take everything, you subtract up to the number before it, then you get the N term. Okay? You may pause this video, rewind it, and take a look. Now next, I'm going to show you an example. What does it mean by sum to infinity when you will need to use it? It is on a decimal place. Example. Let's say recurring decimals. Convert a recurring decimal to a fraction in the simplest form. So it says 0.3333 dot. In some books, it will represent by 0.3. You get a dot because this 3 is where it's being recurring. So this is those equation, and this is one of those question. You need to get the fraction for this decimal place. So we write this. If you want to rewrite this, 0.33333 dot is basically equals to 0.3 plus 0.03 plus 0.003 plus so on and so forth. I just need the first 3 digits. Obviously, this is GP. Geometric progression. Our common ratio is 0.03 over 0.3, which is equals to 0.003 over 0.03, which turns out to be 0.3 over 3, which is 0.1. So 0.1, since it's they want it in fraction form, it's 1 over 10. So it's advisable to use common ratio in a fraction because they ask for fraction. So then, therefore, in order to get into this final form, all I need to do is to sum them. To sum them, therefore, is sum infinity is equals to A. A is 3, 0.3. This is my A. So 0.3 you convert to fraction is 3 over 10. A over 1 minus R. 1 minus R is 1 over 10. Therefore, it is 310 over 9 over 10. Switch it around, therefore it's 3 over 10. Divide, then it would be times 10 over 9. So 10, 3, and 3, that would be 1 over 3, which is here. It's 1 over 3, simplest form. So this is how you will use it. For sum to infinity, GP, geometric progression, it's quite simple and straightforward. Times allowed, I will try to make it in a half an hour for every video. Let me give you another example for geometric progression. You may of course refer my video before you start. It's always, it will take about 2 weeks to practice on one subsection. 20 questions. per video. Watch. I'm going to do practice. Example 2. Says someone need to have his house installment. Let's say installment January. On January of 2004, initial amount would be 7,200 every year, yearly. So increase payment 4% of previous year payment. So you would expect first year is 7.2, second year would be 4% increase is 104%. So on and so forth. Meaning the first year it pays 7,200. The following year he increased his installment by 4%. So you expect 104% the second year. So obviously this is one of those geometric progression because increase 4% every year. Maybe then third year is also 104, but the sum would be actually different. It's not the arithmetic way of adding. It's a compound interest kind of adding. So this is obviously a geometric progression in one of those past year, 2008. So solution. Calculate his annual payment to the nearest ringgit for the year 2010A. Ask for annual payment for the year 2010. So to do that, first of all, you determine what's the A. First term, 7,200. Common ratio, 4% increment every year, so it's 1.04. In order to get the annual year payment, 2004 to 2010, they are total of 7 years. Please take note about it, not 6 but 7. 4, 5, 6, 7, 8, 9, 10. 7 years. It is important here because if you get it wrong, it's quite common for students to think that it is only 6, but it's actually 7. So therefore, my Tn would be equals to AR n minus 1. So therefore, T7 would be 7200, 1.04, 7 minus 1 is 6, power 6. Put in the calculator, that would be 9110.3. Next, B. We ask for the n year, n year, where the payment exceed 10,000. Find the nearest value of n. Now, this kind of question is a log. You need to use a log because of the term term number. So the end year payment exceed 10,000. So you need to use the term number, meaning Tn more than 10,000. To do that, this is therefore ARN minus 1 greater than 10,000. I have my first term already. I know my common ratio, that's why it's important. N minus 1 subtract 10,000. It's important to know in order to get the index number. In my Form 5 video, I've made those videos available online. You may go refer to the law, those law involved in logarithm. In order to get the index number, you use log. What you do, you log both sides. The power term you bring to the front is n minus 1 times log base 10 to 1.04 is greater than log 10. You bring down 7,200. That would be a number which is equals to log 1.3889, maybe 10,000 divided by 7,200. We cancel down. You get about 1.38. Calculator, again, simplify them. N minus 1, be aware that this is a log of a number greater than 1 is positive number, so bring it down. It doesn't need to change the sign. If this number is less than 1, you bring it down, you need to change the sign. So this is not the case. This is still a positive number, so it's log 10, 889 over log 10. It's not subtract, it's over them. You treat the whole number as one entity, just divide them, and it turns out to be n minus 1 is greater than 8.376. Bring 1 over, 8 must be greater than 9.376, and therefore the least value of n, is 10. Okay, I think basically the variant of question, you may be able to find it from a textbook and reference. You may post me a message through my YouTube channel or maybe through my blog. Any question you're unclear, I will try to make another video. Or otherwise, you may attend those tuition session, or maybe in the classroom session. Or perhaps you may ask your friends around during study group session to solve more problems regarding geometric progression. Each video that you have watched from my blog about this open courseware, you're supposed to get about 20 to 30 questions of exercise in a week or two. Otherwise, you will not be able to rush for the exam by the end of the year. Well, that's all for this round. I hope you enjoy my video. Stay tuned to my next video. Thank you.